All right, so this is for dynamics, quiz 5, the chapter 15. So, pretty straightforward. Basically, the question gives us an acceleration in terms of theta and negative k, um, which is fine. But because this is, not a constant, we know there's going to be some calculus somewhere in there. And it also gives us some initial conditions. So we know that angular velocity at 0 is 13.6, and at 6 radians, the angular velocity is 0. So we can use these to solve for this. And how we do that is using these relationships. It's just like the very beginning of the class, but for angular, uh, um, angular momentum acceleration and d theta instead of position. So we know the position over time was going to equal the angular velocity, and we know the angular velocity over time was going to equal the acceleration. So I basically just plugged in the acceleration and just integrated this. I was supposed to move. Actually, no. Yeah, and I actually just integrated that to solve for the angular velocity with respect to time, in terms of negative k theta. So because it's an indefinite integral, I did have to add in a plus c, which you can actually solve for by using the first set of initial conditions, because it gives you a theta of 0, which will actually eliminate that k value completely. So we know that c is going to equal 13.6 because that's the angular velocity when the angle is 0. So c is 13.6. So the next thing, we use the next set of initial conditions. Now the angular velocity is 0 and theta is 6. So we can use that to solve for k now that we have solved for c. We no longer have two variables. So 0, solve for negative k. That's going to give you 0.75 by 6. Sorry, it's positive, and the function itself makes it negative. So lastly, you can just plug in what we're trying to solve for, which is the angular velocity with theta is 3.9 radians. So you can just plug that sucker in, 3.9 squared times our k value over 2 plus our c value gives us an angular velocity of 7.9 rads per second. So pretty straightforward. Thanks.